We had a request for 44 out of 1.2, and this one is about finding the end behavior models for this rational function. So again, end behavior model is a function that sort of replicates the behavior as x goes to infinity or as x goes to negative infinity. So the ends of this graph, but a much simpler function. And we know from earlier that an end behavior model of a polynomial is just the leading term of the polynomial, whatever term has the highest degree. And it kind of holds true for rational functions as well, except you play it with the leading term of the numerator over the leading term of the denominator and see where that gets you. So for our end behavior model on 44, we are looking at a negative x to the fourth over an x squared, and that's going to simplify into negative x squared. So hopefully this function replicates what this function does at either end of the graph. So let's go ahead and check that in Desmos to make sure this does exactly what we think it does. So here we are with f of x is equal to negative x to the fourth plus 2x squared plus x minus 3, and on bottom x squared minus 4. So there's the graph, okay, and we're saying this is modeled on its ends by negative x squared. And interestingly enough, this doesn't appear to be the same at all. And we've got obviously part of the graph of f. It looks like it's going up. The graph of g looks like it's moving down as we move towards infinity or negative infinity. But you got to remember, this is end behavior. And the viewing screen that we have right here doesn't necessarily tell the whole story. So let's begin to zoom out and zoom out a little more and a little more. And hey, there are branches of f of x that I didn't even know existed. And as it turns out, our graph g of x and the original function, much more complicated, f of x, are basically on top of each other as this function starts to get larger and larger and larger, or smaller and smaller and smaller. And that's what an end behavior model does. So there's our answer for this one, negative x squared.